Welcome to School of Chemistry. In today's lesson, we're going to be looking at the formation of covalent bonds and the types of covalent bond. In our previous video, we have discussed how ionic bonds are formed by the transfer of electrons from one atom to another. And we have established that the reason for any type of chemical combination at all is for elements to attain what the duplet and octet structure, which confers stability on them. In ionic bonding, it involves transfer of electrons from a metal to a non-metal. But when dealing with atoms of non-metal, like two atoms of fluorine, what happens? When two atoms of fluorine, which are all non-metal, goes into chemical combination, what happens? As you can see, in the atomic shell of fluorine, there are 7 electrons. It needs one more electron to attain the octet structure so it can gain stability. Also, in the second atom of fluorine, there are 7 electrons, and it also needs one more electron to attain octet structure so it can gain stability. So they go into electron sharing by donating 1 electron each to gain stability. This mutual sharing of electron leads to bond formation. You see, they have donated one electron to each other, and they are sharing that 1 electron. Now this will give each shell now 8 electrons in the atomic shell, and octet structure confers stability on any element. So this mutual sharing of electron leads to bond formation, and the bond is called a covalent bond. So let me define a covalent bond. What is a covalent bond? A covalent bond is the bond formed by what? Mutual sharing of electrons between atoms. I repeat. A covalent bond is a type of bond formed by what? Mutual sharing of electrons between atoms. So when electrons are shared between atoms, a covalent bond is formed. You must know that. And also, covalent bond is formed between non-metal. Let's look at how shared electrons move in covalent bond. Let's look at the covalent bond in fluorine molecule. These 2 atoms share 1 electron each to form a covalent bond, as you can see. This shared electron, this is the shared electrons. Each of them has contributed 1 electron each to form the shared electron. So now, this shared electron belongs to this fluorine atom, and it also belongs to this fluorine atom. You can see that this fluorine atom has 50% ownership, and this fluorine atom has 50% ownership of the shared pair. And therefore, we can say that the shared electron move in orbital around the orbital of both atoms. Let me repeat. The shared electron moves around the orbital of both atoms. So we say that the shared electron belongs to both fluorine atom. It belongs to this fluorine atom, and it belongs to what? This fluorine atom. So that is it. Now, let's look at the types of covalent bond. First, let's look at the single covalent bond. In the single covalent bond, this type of covalent bond, 2 atoms mutually share 1 pair of electrons. For example, let's consider 2 hydrogen atoms. We can see that this hydrogen atom has 1 electron in its atomic shell, and also this hydrogen atom has 1 electron in its valence shell. So they will go into chemical combination by sharing 1 pair of electrons to form a covalent bond. So each of them will contribute 1 electron to the shared pair to form a covalent bond. We can see that this is the 1 pair of electron. This is a 1 pair of electron shared by the hydrogen atom, and the duplet structure for each of the hydrogen atom is attained, and hydrogen molecule is formed. You know the duplet structure, you have 2 electrons in the atomic shell. Note, a single line between the 2 hydrogen atoms represents a single covalent bond. Another type of covalent bond is a double covalent bond. This is the type of covalent bond in which two atoms mutually share two pairs of electrons. For example, let's consider two atoms of oxygen. We can see that the atom share of oxygen, there are 6 electrons, and it needs 2 more electrons to gain stability. Also in the second atom, there are 6 electrons and needs 2 more electrons to gain what? Stability. They will go into combination by what? Sharing 2 electrons each. Each of them will contribute 2 electrons to form a covalent bond. When you do that, you see that each of the atoms is having 8 electrons in the atom share now. So when they share this electron, they attain the octet structure and they gain what? Stability. Note, 2 lines between 2 oxygen atoms represents a double bond. 2 lines between 2 oxygen atoms represents a double bond, and each line represents what? A shared pair. So since there are 2 shared pair, we have 2 what? Double bond between the oxygen atom. Let's look at the third type of covalent bond, which is the triple bond, the triple covalent bond. In this type of covalent bond, we have 2 atoms sharing 3 pairs of electrons. For example, let's consider 2 atoms of nitrogen. 2 atoms of nitrogen. These are the 2 atoms of nitrogen. You can see that there are 5 electrons present in the valence share of this nitrogen, and it needs 3 more to attain stability. Also, there are 5 electrons in the second atom and needs what? 3 more to attain stability. The 2 nitrogen atoms will go into chemical combination by sharing 3 electrons, form what? A covalent bond, and a molecule of nitrogen will be formed. So the first nitrogen will donate 3 electrons in combination, and the second hydrogen will donate what? 3 electrons, so that they can form what? 3 bonds. So we're going to have 3 pairs of what? 3 shared pair. Each of the nitrogen donate. You can see this is the first shared pair, the second shared pair, and the third. These are the 3 pairs of electrons. Now, if you count, we are going to have 8 electrons in each shell of the nitrogen. When you have 3 lines between 2 nitrogen atoms, a triple bond is formed. Note, when you have 3 lines between 2 atoms of nitrogen, a triple bond is formed. If you find this video helpful, please click the subscription button, share, like, and comment.